Hi, welcome viewers to this particular video on longitudes and latitudes and also probability. I have a first question here that I want us to do, and it reads: a city P is 30 degrees north, 31 degrees east, and another city Q is located at a distance of 4,365 nautical miles east of P. Find the position of Q, right? So the first thing we need to do in order for us to do this problem, we need to make a geometric sketch of these two towns. So we will draw simple sketch of the earth here. That's enough. Then we locate the two towns on the earth's surface. So the first one is 30 degrees north, and it's also 31 degrees east. It's always good to have a good diagram in order for you to have a geometric intuition of what you're dealing with. So this is point P, right? And I call this one longitude 31 degrees east, right? Then we have this town that we are calling Q is located at a distance of 4,365 nautical miles east of P. So we know that if P is here, so this is to the east. So you'll have another town here. So it's just but a sketch, so it doesn't matter. So this is Q. And so we know that these two towns are lying on a small circle, since this one is not equator. We know that small circles include any other circle except the equator and the longitudes. So this is one of the small circles. And we know very well that for distances in nautical miles, let's say, along the small circle is 60 theta cosine of alpha. I want to explain what theta is. So theta is nothing but the longitudinal difference between the two towns. So this is the longitudinal difference between the two towns. And then we have alpha is going to be equal to the latitude value, okay? Latitude value, so latitude value on which the two towns lie, okay? So we can now, because the distance given here, it's given in nautical miles, so we are going to use this formula here. But of course, if you're asked distance in kilometers, I want to give you this one. We have theta over 360 2 pi capital R, the radius of the earth, and also cosine of alpha. Now the two values, that is theta and alpha, still hold true for the two explanations given here. Okay, so let's go straight and use this formula of 60 theta cosine of alpha. And this is equal to the distance we're talking about. And since we're given distance as 4365, so we are going to equate to 60 times theta. Of course, by the way, in this question, we don't know theta, but we already know alpha, which is this here. Okay, so 30 degrees each. So we have 30 degrees. And so theta is going to be equal to 4365 divided by 60 cos 30, right? If you conduct your computations here, you're going to have a 4365 divided by 60 times root 3 over 2, you know, cos 30, and this gives me 4365, I should say, 30 root 3, and this gives me an angle of, if you compute, you get 84.00, so that's 84 degrees. But we are already having 31 degrees to the east here, where we have P, and we want this coordinates here. So we should say it's 30 plus this angle here. So we are going to take now 31 plus 84 degrees, and this is going to give us 115 degrees east. So this Q, this one here, is going to be equal to 30 degrees north, 115 degrees east. And this is what you do whenever you're given, let's say, the two towns and you want to determine the distance. Usually take the longitudinal difference between the two towns, which is 115, and in this case 31 degrees, and from there you use the formula of distance to compute in nautical miles, which is 60 theta cos alpha, and that's how it's done. Thank you.